Welcome. Today we are going to look at a case where we are given a cantilever beam which is loaded with a point load of 20 kilonewton, 10 kilonewton, 30 kilonewton. We have support at point A, then we have a loading at point B, C, and D. From the question, we are required to determine the reactions, and hence we draw the shear force and bending moment diagram. So this is a cantilever beam. It is fixed at point A, meaning when loaded, the cantilever beam will bend this way. So we have to calculate for reactions, then we calculate the shear force and then the bending moment diagram. In this case, the reactions will only be at point A because at point D it is not supported. So we are going to add all the loading to react at point A. That is 20 kilonewton plus 10 plus 30 kilonewton. So if we are to look for reactions, because they are point loaded, we are going to add all the loading. So we have reaction at A equals 20 plus 10 plus 30. 20 kilonewton plus 10 kilonewton plus 30 kilonewton, which will give us 60 kilonewton. Then with the reactions, we can be able to calculate the shear force. Our shear force for this one, we have shear force at point D, C, B, and A. And in this case, now that it is a point load and it is on cantilever, on each point we will be having total loading at that point, meaning that at point D the shear force will be 20, at point C the shear force will be 20 plus 10, at point B the shear force will be 20 plus 10 plus 30, then at point A the shear force will be 20 plus 10 plus 30. So basically we start with Q at D, which would be 20 kilonewton, then Q at C, which will be 20 plus 10, which will give us 30 kilonewton. Then we have Q at B, will be given by 10 plus 10 plus 30, which will give us 60 kilonewton. So shear force at point A and B are the same. So Q at A will be the same with this one, which is 60 kilonewton. So with that one, we can now go to bending moment. Remember, moment is given by force times distance. So moment at point D obviously will be 0. Then moment at point C will have it as a 20 times 2. And then we continue to calculate at point B and point C. So we have force times distance. So moment at D, here because we have force weight but we don't have distance, it's like 20 times 0, which is 0. So it is 0 kilonewton meter because there is no distance. 20 times 0. Then we have moment at C. Moment at C now will be this loading times distance, which is 20 times 2, 40 kilonewton meter. Then we have moment at point B, which will be given by 20 times total distance up to B plus 10 times total distance up to B, which is 20 times 2 plus 1.5, that is 3.5, plus 10 times 1.5. And this one will give us a total loading of 85 kilonewton meter. Then we have moment at point A, the last point, moment at A. And this one will be given 20 times total distance plus 10 times total distance, then plus 30 times total distance, which is 20 times 5.5 plus 10 times 3.5 plus 30 times 2. And this one will give us a total loading of 205 kilonewton meter. So with this bending moment and shear force, we can be able to draw the shear force and bending moment diagram. We start with the shear force diagram. That is my baseline. I have 0 and 0. So shear force at point D is 20 kilonewton. So I'm assuming 20 at this point. Then shear force at C is 30. Shear force at B is 60. So I have point of 60, 30 and 20, and I can join the points. It is not into scale. That is the shear force diagram. Then we can hack this one. Let me in this case use a different pen. So it's positive. So that is the shear force diagram. We can now sketch the bending moment diagram. It's not to scale. So we have my baseline, point 0. Moment at D is 0. Moment at C is 40. Moment at B it's 85. Then moment at A is 205. So we have this point, this one, and then 0. So we can join this using a ruler. And my moment here is negative. So we are able to solve our question by determining the reactions and then having the shear force diagram and then the bending moment diagram. So join me in my next lesson where I'll be handling a question of the same cantilever beam, but now it will be having a uniformly distributed rod and also a point rod. So meet during our next lesson. Welcome and thank you.